right, this is number 16 from your 4.1 through 4.3 quiz review, and it said to sketch a graph of the following polynomial. So it's f of x equals 7x to the fifth minus 14x squared minus 21x to the third. So we know that polynomial functions are smooth and continuous. So we know there's not going to be any breaks, there's not going to be any corners or any of that. So the first thing we need to do is try to figure out our x and our y intercepts. So to find your y-intercepts and your x-intercepts, to find your y-intercepts, you make x equal to 0. So if we do that, 0 to the fifth is 0 times 7 is 0. Then we're going to subtract 14. X to the fourth, well, x is 0, so that's all 0. And then this will all become 0. So our y-intercept will actually be 0, 0. So then to find our x-intercept, this is where we set y equal to 0. So I get 0 equals 7x to the fifth minus 14x to the fourth minus 21x to the third. Once I do this, remember this is to find my intercepts in my graph, my x-intercepts. So to solve this, well, you usually want to try to get x by itself, but because of the exponents, I can't truly get x by itself. So the only way to solve this is to put it in factored form. So the first thing I'm going to look for is there one number that I can take out of everything? And there is. I can take out a 7 from all of these, and I can take out an x cubed from all of these. So when I factor that out, I get 0 equals 7x cubed. If you factor out a 7x cubed from 7x to the fifth, you're left with 1x squared. If you factor out a 7x cubed from negative 14x to the fourth, you get negative 2x. And if you factor out a 7x cubed from negative 21x cubed, you're going to be left with a minus 3. So then I have 0 equals 7x cubed times all of this. And this is a quadratic. So now I can factor this like I would normally a quadratic. So I want to think of what multiplies up to negative 3 but adds up to negative 2. Well, that'll be negative 3 and positive 1. So when you factor that, you're actually going to end up with x minus 3, x plus 1, and then all of that is still times by 7x cubed. Now, because it's equal to 0, because we're finding our y-intercepts, or our x-intercepts, I'm sorry, because we're finding our x-intercepts and we set y equal to 0, we know anything times something, if it equals 0, that one of these has to be equal to 0. So we take each one of them and set them equal to 0. And if I go to solve this, here I get x equals 0. Here I would get x equals positive 3, and here I get x equals negative 1. So that means I have intercepts at 0, 3, and negative 1. So I'm going to go ahead and start my sketch because I know where it's going to cross my intercepts at. So I have one at positive 3, and remember it's just a sketch, so it doesn't have to be perfect. I have one at negative 1, and I have one at 0. So that's your first step. And actually, remember our y-intercept was 0, 0, so we technically already knew one of our x's had to be 0. Now, if you remember, to figure out exactly what's going on, we have to find the end behavior model of this function. So to find the end behavior, we take limits. We have the limit as x approaches negative infinity of 7x to the fifth minus 14x to the fourth minus 21x cubed. And we have to do the limit as x approaches infinity of all of this. And remember, when we're dealing with polynomials, when we get out in the millions, this x to the fifth is growing really, really, really fast. In comparison, this x to the fourth and x to the third are really doing nothing. So we know this is going to mimic the limit as x approaches infinity of 7x to the fifth. Same with the top one. When we get that really large negative numbers, these are not going to matter. It's like if you're a millionaire and you lose $1, it's not going to change much. So it's going to mimic the limit as x approaches negative infinity of 7x to the fifth. Since it's odd, we know odds start in one quadrant and end up and finish in a second quadrant. They end up going in different directions at the ends. And then because of our lead coefficient being positive, we know it's going to do what a traditional odd function would do. So, and if you couldn't remember, you could plug in really big numbers and see what happens. But normally an odd function, we did this in 2.2, starts in the third quadrant and ends in the first. And since it's positive, that's what it's going to do. So we know it's going to start down here and end up here. Okay? Then we just have to figure out what's going on in the middle. That's when we look at our multiplicity, which remember is how many times it shows up. Well, x plus 1 shows up once, so this has a multiplicity of 1, which means it's going to show, just cross through at -1. So as I'm going through -1, I'm going to cross right through it, and at some point I have to come down to reach this other intercept. And if I look at that, that's my 0, 1. Well, 0 is from 7x to the third, so because it's cubed, it has a multiplicity of 3. And remember, when it has multiplicity of 3, that means it's going to saddle through that point or switch concavity. So you just draw it switching concavity. And then at some point, it's got to come up to go through our next point. And if you really can't draw a saddle, it's fine if you just draw an arrow saying, hey, this is a saddle. Because I know that can be kind of difficult. And then we look at this last root. It's at x equals 3. Well, x minus 3 showed up once, so this has a multiplicity of 1. So it's just going to go straight through that x-axis. And then you have your sketch of the drawing. See, it's smooth and continuous. There's no sharp corners. And remember, it's just a sketch, so we don't care how far up or how far down you go. And then these are considered your end behavior models. So if it asks for this, you need to write the limit. And technically, I didn't finish it. We know as we go to negative infinity, our function also goes to negative infinity. And as our function goes, as x goes to infinity, y also goes to infinity. So that's how you do number 16. Here's a whole view of the whole thing. So remember, your first step was finding your x and your y intercepts and then graphing those. Then figuring out your multiplicities and your end behavior and just sketching in the known details.